Hello everyone, I am Jagdish Patel, Assistant Professor, Sandhi Foundation, Nasik. The name of subject is Digital Circuit. This is Unit 1, Digital Logic Families. And today this one is lecture number 3, in which we are going to see TTL Logic Families. I am having 12 years of teaching experience, specialization in digital communication. So TTL Logic Families, TTL stands for Transistor Logic. In the starting of this lecture, starting of this unit, lecture number 1, we have seen the definition of TTL, and now we are going to see the details about TTL logic families and their operations. Operation of TTL NAND gate. This one is a structure in which this first section is diode equivalent for Q1. Here, this one is Q2 transistor. This one is Q1 transistor. Here again, this section, detail of this section are given in the left hand side, which consists of 3 diodes labeled as D2, D3 and D4. Internally, they are connected to Q1 transistors. That's why it is called as transistor logic. Here, after that, the output of this one is base terminal, this one is collector terminal, this one is emitter terminal of the transistor. And here, this is the operation of TTL NAND gate, which consists of Q1 transistor, Q2, Q3 and Q4. There are 4 transistors which are connected as shown. Now, TTL NAND gate for low output. So here we are applying the signal from A and B inputs, which is passing through transistor Q2, which makes it on. After that, we are getting the output at this X and ground section as a low output. So that's why the structure gives TTL NAND gate low output structure. A TTL output acts as a current string in a low state because it receives the current from the input of the gate that is DRAM. Transistor Q4 of the driving gate is on an essential short point X to ground. Low voltage of X forward bias the emitter base junction of Q1. Here is the emitter base junction of Q1. And current flows back through Q4. See here, the current from the second section is flowing back to the first section. That's why this operation is called as current sink. Now Q4 is performing a current shrinking action, driving its current from the input current IIL of the load gate. Q4 is often called current shrinking transistor or pull down transistor because it brings the voltage, output voltage, down to its low state. That's why it is called as low output TTL NAND gate structure. TTL NAND gate high output structure. Here we are applying 5 volt supply to point A and point B is grounded, so that the current coming from the collector or from the above section will be grounded from B point. Which makes diode D4 off. So because of this, Q2 will also become off and Q4 will become off and Q3 will become on. So here we are getting the output between X and grounded section as a high output. So that's why the structure is called as TTL NAND gate high output structure. A TTL output acts as a current source in the high state. The transistor Q3 is supplying the input current IH required by Q1 of a load gate. Q3 is often called current sourcing pull-up transistor. In more model TTL series, the pull-up circuit is made up of two transistors. Here if you see, the current is coming from plus 5 volt supply passing through Q3, makes it on. After that it goes through the second section of Q1, and in this way this action is called as current sourcing action. Totem pole output stage. The arrangement of Q3 and Q4 on the output side of TTL NAND gate is called as totem pole arrangement. So now what are the advantage of totem pole stage? First one is the current flowing through R3 will be equal to 0 when the output Y equal to 0. That is, when Q4 is on, it reduces the power dissipation in the circuit. When the output Y is equal to 1, here Q3 will be on and acting in the emitter follower mode. T therefore will have a very low output impedance, that is 10 ohm. Therefore the output time constant will be very short for charging up any capacitive load on the output. Disadvantages of totem pole stage. We have seen the advantages. Now we are going to see the disadvantages. The first one is Q4 in the totem pole output turns off more slowly than Q3 turns on. So before Q4 is completely turned off, Q3 will come into condition. So for a very short duration, a few nanoseconds, both the transistor will be simultaneously on. This is called as cross condition, and it will draw relatively large current 30 to 40 milliampere from the 5 volt supply. So these were the advantages and disadvantages of totem pole output stage. Now IC interfacing. Interfacing means connecting output of one circuit system to the input of another circuit system. The simplest and most desirable interface circuit between a driver and the load is direct connection. Often a direct connection cannot be made due to a difference in electrical characteristics. An interface circuit is connected between the driver and the load. To condition the driven output signal so it is compatible with requirements of the load. IC interfacing includes driver and load, and which are both the driver and load are interface. So this configuration is called as IC interfacing. This shows the voltage parameters for the interfacing. Here this VOH and VOL are the output voltage, high and low. This is VIL and VIH. These are the input voltage, high and low. And after interfacing, we are getting this type of graph and the parameters. This is another representation of IC interfacing. Here driver is interface with the load. The same diagram as seen in the last slide is represented in different fashion. External pull-up register is used when TTL drivers CMOS. When we are going to use TTL and CMOS, the pull-up register plays an important role. So here if you observe, in the first NAND gate there is TTL and second NAND gate there is CMOS, and both are interfaced with each other with the same concept as we have seen in IC interfacing. This is equivalent CMOS output circuit for both logic states, high state and low state. Comparison of logic families. So these are the different parameters we have seen in the last lecture: power dissipation, propagation delay time, maximum clock frequency, speed and power product, minimum output driver, fan out, maximum input current. So these are the parameters which decide the performances of digital ICs. It may be CMOS or it may be TTL. And here these are the different series of CMOS, that is 74HC 4000, and after that there are the different series of TTL, that is 74, 74LS, 74S, 74ALS and 74AS, and each configuration or each series is having different values of the parameters or the characteristics which decides their performances and which are listed here for your reference. So in this way we have seen the detailed parameters and the structure used for the performances of TTL logic families. Thank you.